were interested by this collaboration with Prilenia that asked us to test whether actually Pridopidine was able to promote the functioning, the recovery actually of the mutation by this molecule. And so what we did was so we are using microfluidic chips that actually reproduce this corticostriatal projection. I can just show you one. I have I don't know whether this is visible here, but this is the type of little microfluidics, so that are very small. If I just put my finger close to it, and with this type of things, we are actually reproducing the corticostriatal projection, exactly what happened in the brain, and we are able to treat the neurons with drugs. And we've been following up the trafficking of BDNF in that circuit, and we found that Pridopidine was able to restore trafficking. So that's and we also found that it was restoring the synaptic transmission. So which is pretty cool, because that means we are in this molecule is this assay is quite predictive. So we have also last year published a paper about another molecule that could help to restore trafficking, which is acting different mechanism from Pridopidine. So Pridopidine is working through the activation of the sigma-1 receptor that probably promote BDNF by increasing neuronal transmission by the via release of calcium from the endoplasmic reticulum. So that's one mechanism. We have also a project based on another molecule that we are following up, and that facilitate the fluidity of the membranes, and that probably help the trafficking of the vesicle into the neuron. So that's also one molecule that is, I would say, of therapeutic interest, but needs like much more preclinical work before it can be used in patients. But that, I think we have strategies on the pipeline. It might take some years for some of them, but hopefully we believe, actually, one thing that we really strongly believe is that axonal transport is really a pathway that is absolutely critical for brain communication, that is altered in Huntington disease, but in fact, not only in Huntington disease, but in many other neurological disorders. So there are several neurological disorders that are associated with mutations or alteration of protein involved in intracellular trafficking or axonal transport. And so we believe axonal transport is a very interesting therapeutic target in the future.